Hello and welcome to Build a Skill with me, Bill Haining. In this session we're going to look at number basics. Now the aim of this session is to deliver learning that will provide the required knowledge to support learners in completing the Level 1 and Level 2 Maths exam. Now the objectives of this session is to work with and understand place value, work with positive and negative numbers, calculate in values of tens, work with and understand powers and roots, add and subtract, multiply and divide, rounding and estimating, and checking your answer. Number 1, place value. Now, place value is a fundamental concept in mathematics that helps us understand the value of each digit in a number based on its position. In functional skills maths, understanding place value is crucial for performing operations, reading and writing numbers, and solving problems. The position of a digit within a number determines its place value. Each place value is 10 times greater than the one to the right. So if we start from the right here with a single unit, we move one place to the left, you can see that we multiply by 10. We do the same and we move up in values of 10. So 10 times 10 is 100, 10 times 100 is 1,000, 10 times 1,000 and so forth, right till we get into the millions. Now make a note that every third position from the right should have a comma or a space. And there's your commas where they should be suitably located. So let's look at whole numbers. In the number 4, 5, 6, the digit 6 is in the units place, the digit 5 is in the tens place, and the digit 4 is in the hundreds place. Okay, so what are the place values? The biggest mistake here is people forget about place value and they get this part wrong and they can lose silly points. Okay, so therefore the place value of the 4 is 400 because you can see the 4 is in the hundreds column. Okay, so it has a value of 400, and similar with the 5, it's in the tens column, so it has a place value of 50. All right, and the 6 is in the single units column, so it has a place value of 6. Now understanding place value helps us compare numbers, order numbers, perform addition and subtraction, work with decimals. It also provides a foundation for more advanced mathematical concepts. So it's vitally important you understand how place value works, and you'll see later on in the session some examples. Now let's look at decimals. Decimals are numbers that fall between two whole numbers. For example, the number 2.562 is a number between 2 and 3. Okay, you can see you're starting from the units, but instead of multiplying, you're dividing it, you're breaking it down in values of tens. So one single unit divided by 10 will give you 1/10. A tenth divided by 10 will give you 100th with a th. All right, and 100 divided by 10 will give you 1,000th. All right, and you can see the more you move to the right, the less of the value. Therefore, the place value of the numbers in decimals are the 5 over 10. You can see there the 5 is in the tenths column, so therefore it's 5/10ths or 5 over 10. And if you know fractions, that's the same as a half. Okay, the 6 is in the hundredth column. Okay, so it's 600ths, all right, or 6 over 100. And the 2 is in the thousandths column, so it has a place value of 2,000ths. And again, you can see the fraction version of that. Now let's look at a typical style exam question at level 1. It says there, write 870,205 in figures. Again, an area where a lot of learners make mistakes. All right. What I like to say, and it doesn't work on all occasions, if you think of this word and as a 0, all right, it works in about 95% of the time. But let me just show you what I mean by that. Right. So there's your place values. All right. And if you write this numbers here and where they should go in their place value, so you can see there you have 800, right, and 7. That's where you sort of substitute the and for a 0. Doesn't work in all occasions, but for the majority it works. So it's £807. And for example, if it was money, and 205, 205. All right, because your 2 is in the hundreds column. All right, your 5 is an individual unit, and so the gap in between is and. Okay, and that there is how you write that in numerical value, but don't forget to put your comma in every third, or a space every third value. All right, and there, as you can see, where the word and comes in handy. Okay, when you're writing something that's written into a number. Now, for example, a rugby match, 19,417 home fans and 2,648 away fans attend. Okay, align the numbers to their place value. All right, and you can see the space there gives you a clue. So there's your 19,417, and you line up the spaces. You can see you're lining up the spaces there, and that tells you now that these numbers are in the correct place value. Then you just simply add them up. All right, and you can see the answer is 22,065. Now here's another typical level 1 question. It says, which of these lists of decimals are increasing order? All right, that means from small to large. All right, it says tick the correct answer. Now the first thing you may note, as you can see at the bottom there, all the numbers are the same. They're just rearranged differently. So all you have to do is focus on one set of numbers, right, and start comparing them. And this is how you do it. Imagine you're in an exam situation. Just rewrite the numbers again, the 4 numbers down again. You can see here if you align the numbers according to their place value, okay, and there's how you line them up. You line them up to make sure that the decimal point is where it should be. And what happens there is the numbers then fall into their proper place value when you're dealing with decimals, especially. Now, you can see here, you may just assume that 401 is bigger than 420. You may assume that 503 is bigger than 59, but you would be wrong, because when you put them into the proper place value by adding zeros, so you've got to pad them out with zeros, all right, to show their true place value. And there you go, you've now added your zeros. All right, and you can now see that actually 0.42 is actually bigger than 0.401, okay, because that's its true value. And you can see that 0.59 is actually bigger than 0.503 because its true value is 5.590, okay. All right, and based on that information, you just simply rearrange them from large to small, or small to large. And you can see there's your smallest, there's your next smallest, there's your third, and there's your biggest. Okay, and based on the information, you can tick off the answer you think is correct, in this case, A. So don't fall into the trap. Make sure you pad out, align them up, and then pad out your numbers with zeros. Now this is a question that comes up just about every time I see it. Most learners get it wrong, okay? And you can see here you're asked to divide 0.06 million divided by 6.2 thousand. And believe it or not, this is a calculator paper, but most people get it wrong because they don't understand about place value, right? And you can see it says give your answer in 2 decimal places. So let's think about the place value. Where would you fit? Let's deal with the million first. Let's deal with this 0.06 million. Okay. Now, if you think about it, right, all you do is align that 0.06 up, starting from the millions position. But as you can see, there's a clue there, millions. All right. So you start the 0 from there. So you can see there, its true place value, 0.06 million. In other words, 6,000. So what you do is you pad it out with your zeros, all right, and you can drop the zeros at the front there. You don't need them when you're dealing with whole numbers. And you can see that 0.06 million is just the same as 60,000, okay. And you do the same with the second part here, okay, with the thousands, okay. You start in this thousands column, okay, and you can see there's your 6.2 thousands, all right. That's a great thing about working in values of tens. Okay, you just slot them in just nicely like that, add your zeros, and you can see that 6.2 thousand is the same as 6,200. Okay, and from that, then you can get your calculator out and do the calculation. 60,000 divided by 6,200 equals 9.67, and a big long number And you can see why the question says give your answer to 2 decimal places. And that means that you have to stop here where this first 7 is. All right, you stop at the first 7, you look at the number next door, and you can see it's higher than a 5. So that number there, 7, changes to an 8. And so therefore the answer is 9.68. Okay, and that's all done by knowing its true place value. All right, so let's hope you never get a question like that wrong again. Now you can have a go. All right, you can pause this video and you can try the questions that's coming up and see how you got on. Okay, so what's the value of 2 in the number 328407? And you can see it's 20,000. All right, because it is in the 10,000 column, the 2. Okay, so it has a place value of £20,000. If you got 20,000, well done. All right. Now there are 59,182 fans at a football match. What is the value of the 5 in the number 59182? And if you got 50,000, then well done. Now it says here circle the value of the digit in 0.073. So we're looking for the 7. What is the value of the 7? So think about the place value. What place is it in? Now if you remember, okay, the first one here where the 0 is, that's in the 10th column. The 7 is in the 100th column. So there's your clue there, that's 100th. So if you got 7 over 100, then well done. Let's look at skill 2, positive and negative numbers. Now let me introduce you to positive and negative number lines. As you can see how it's laid out. To the right of the 0, which is the origin, you have positive numbers. Now this is what we recognize with whole numbers. Okay, you can see there's no symbol in front of them. So therefore, we generally class these as positive numbers. Now just a tip to remember when you're dealing with positive numbers, anything over 0 is a positive number, and this includes fractions. So always remember fractions are more than 0, so they're a positive number. Now anything to the left of the number line is called a negative number, and you can see as the number gets larger, going from right to left, then the value decreases. Because if you imagine if that was temperature, for example, minus 10 is colder than minus 1. So therefore, as the value or the number gets bigger, the value gets less. Okay, here's an example. Okay, now 3 minus 6, working with the number line, which will help you deal with positive and negative numbers. Okay, you start at 3, which is a positive number, and you work backwards 6, because a negative number means you move to the left. So 1, 2, 3, 4, 5, 6 means that the answer is minus 3. And you can see that there. Now minus 3 plus 9, here's another example. Now you can see there's a minus in front of that there. So what you do is you start from minus and it's add 9. So it's 1, 2, 3, don't forget the 0, 4, 5, 6, 7, 8, 9. So you can see the answer there is 6. And that's how you use positive and negative number line. Right, have a look at this one. You have a go. All right, again, stop the video if you think you can calculate the answer and see how you did. All right, so you can see here, minus 8 plus 13 should be, all right, 5. All right, so you start at minus 8, move 13 places to the right because it's positive. Remember, positive go to the right, negative go to the left. All right, let's try this one, 60 minus 80. Okay, again, you're starting a positive number 60 and working backwards, you deduct 80 and you can see you end up at minus 20. All right, so minus 20 is the answer. Let's have a look at another one, 150 plus 200. Sorry, a minus 150 plus 200. So your starting point is at a minus 150. You move 200 places to the right because it's positive numbers, okay, and you end up at 50. All right, so you can see now how positive and negative number lines work. So don't get caught out in the future. Now let's look at skill 3, calculate in values of 10. Now multiply and divide whole numbers and decimals by tens, hundreds and thousands, anything with a 0 basically. Okay, So to multiply in values of 10, you move the decimal point to the right depending on the number of zeros. For example, 10 times 2.4. And you can see there's one zero in there, so you take the decimal point, move it one place to the right, and you can see the answer is 24. Okay? Now 100, you can see in 100 there are two zeros. So you take the decimal point. Now this is a point that you may not realize. You can see the number 24 there. It doesn't show the decimal point, but it's there. It's invisible, but it's there to the right hand side of the 4. All right, that could be written as 24.0. All right, so all you do is you move the decimal point two places to the right and add zeros like this here. So basically you're just taking these two zeros and putting them on the end when you're dealing with whole numbers. Decimals is slightly different. Okay, and now multiply 1,000, 2,400 by 1,000. You can see here you've got three zeros, and all you're really doing is you're adding the three zeros to the end. All right, but in reality you're manipulating the decimal point. You're just moving the decimal point three places to the right and padding it out with zeros. Okay, now that's important when you're doing things like calculating percentages. All right, and you'll see in a second when we do the divide what I mean by that. Okay, so let's look at dividing. Okay, now the opposite applies when dividing in values of 10. Move the decimal point to the left. Okay, so if you take 240,000, divide it by 1,000, that gives you 240. Okay, because all you're doing is you're taking the decimal point, which is here, and moving it three places to the left. All right, and you can see you get rid of the zeros, what's left is 240. All right, you take 2,400, divide it by 100, and you can see there that the answer is 24, because again, all you're doing, because there's two zeros in 100, you just move the decimal point two places to the left, and what's left is 24. All right, and this part here, which is vitally important, all right, you can see here that 24 divided by 10, all you're doing, just like you did with the multiplication, you're moving that decimal point from there in between the numbers, and you get 2.4. Now, when it comes to things like percentages, at level 1, you may be asked to calculate in values of 10 and values of 5. Okay. Now, for example, if you wanted to find out what 10% of 24 was, then you just divide it by 10. So 2.4 is 10% of 24. And if you wanted to find out what 5% was, you would just half that 2.4. So you can see that 1.2 is 5% of 24. So that's the importance of multiplying and dividing in values of 10. You can do stuff really quickly, all right, by manipulating the decimal point depending on how many zeros there are. Right, let's look at some typical exam questions you may come across when you're working through the levels. Now this is a level 1 question. A man puts £3,000 into a savings account. Okay, the interest is 5% per year. How much interest will it be for the first year? Again, stop the video, have a go, and see if you can answer that question. Well, if you think about it logically, okay, you find out 10% first, and you find out 10% by taking the decimal point, moving it one place to the left, and that gives you a 10% value of 300. All right, then all you simply do is take that 300, you divide it by 2, and that tells you that 5% of 3,000 is £150. £150 is 5% of 3,000. So you can see you can do that super quick as long as you remember. Move the decimal point one place to the left. Numbers don't change. £300, half that gives you 5%. Now let's look at a level 2 question. Okay, what is 14% of 200? Okay, again, stop the video if you want to answer this. Okay, now it's fairly simple, right? Here's a nice quick way of doing something like that. Now the word percent means out of every 100. All right, so all you have to do is find out what 14% of 100 is. In this case, it's 14. All right, because 14% just means 14 out of 100. So you now know that 14% of 100 is 14. So 14% of 200 must be 28. Okay. All right, so 10%. You can do it that way if you want. There's another way you can do it. You can do 10%. This is called chunking when you're dealing with percentages. You do it in little chunks. So 10% of 200 is 20. All right. 1% of 200, just divide by 100, gives you 2. And you can add that 4 times. and you can see the answer is still 28. Again, here's another level 1 question. What is 0.4 as a percentage? All right, again, stop the video if you want to. Right, and the answer is fairly simple. All you do is the word percent means every 100. So you multiply by 100, you take the decimal point, move it 2 places to the right, and you can see that the answer is 40. All right, so 0.4 is exactly the same, or is a decimal version of 40%. Now, just one thing to note before we move on to the next question, and this is where a lot of people get it wrong. Anything below 9% is presented in this manner here, 0.0 something, all right, if it's less than 9%. So as you can see there, the best way to do this, if you multiply by 100, you'll never get this wrong. So you start with the decimal point, move 2 places to the right, which gives you 4, drop the zeros to the left, and you can see it's 4%. All right, so don't get caught out with a trap. All right, because it's 2 different values. Now let's look at level 2. All right, what is 0.825 as a percentage? And you can see it looks a wee bit more complex, but how you solve it's just the same. All you do is take the decimal point, multiply it by 100, move it 2 places to the right, and you will see that the answer is 82.5. So it's just the same. So 0.825 is the exact same as 82.5%. Now let's look at skill 4, powers and roots. Now powers, these can also be called squaring when working out the area of a surface and cubing when working out the volume of an object. All right, these will be displayed with a 3 and that little 2, that's called squaring, or 3 with that little 3, or any number with these little numbers, and that's called cubing in that example there, 3 to the power of 3. Now, this is the biggest mistake that people make, right, when they're dealing with squaring, all right? And you can see there, 3 with a little 2. A lot of learners tend to think that means 3 times 2, and you can see the answer is 6. Well, in maths, they wouldn't do that. They wouldn't write 3 to the power of 2 if they just meant 3 times 2, because all they would do is write 3 times 2 equals 6. They wouldn't go to the length of putting that little 2 in there. Why? Because it would just confuse you. So that little 2 must mean something else. Now let me show you, because that is wrong. All right. Now if you take 3 to the power of 2, what it means is this number here, 3, multiplied by itself twice. And you can see it just means 3 times 3. And you can see the answer is 9. Okay. And when it comes to cubing, same thing happens. Now that main number can be different. This number can change, but the little cubing number doesn't. So you can see that just means 3 times 3 times 3, which is 27. Okay, and that is the correct way to do it. So the best way to remember these little numbers that they put next to the bigger number is it doesn't mean multiply. What it means is you take the main number, the big number, and multiply it by itself that many times. And that's a little number. So don't forget that. Now let's look at roots. Roots are the opposite of powers. For example, there's your power. 3 to the power of 2 means 3 times 3 equals 9. Well, the root is in reverse. So you can see 9 divided by 3 gives you 3. So in this case, 3 is the root number. All right, 3 is the root number. All right. Now, with a calculator, it's very easy to do the root number. You just put the number in you want to find the square root of, and you press the square root button on your calculator. But in the non-calculator section, you won't have that luxury of the calculator. But at the non-calculator section, they'll normally give you the easier ones. These are ones you may remember from your primary school days. Okay, and it's worth, if you can't remember them, go over these ones again, and you'll see there it's things like 2 times 2 is 4, 3 times 3 is 9, 4 times 4. So you can see that's probably the most basics. They may do 8 times 8, but that's about as much you would get at level, the non-calculator section, whatever level you're doing. They wouldn't give you something that was really complex. That would probably come under the calculator paper. Okay, so that's your powers and roots. All the numbers in green are the root numbers. and the numbers to the right are all your powers. Okay. Right, let's have a look at level 1 question. Again, stop the video if you need to. All right. Now 25 times 25 is 625. Okay. That's what that means. 25 times 25. Now let's look at a question at level 2. You may get 5 to the power of 4. Okay. Again, stop the video if you want to work that out. Okay. But you'll see all that means is 5 times 5 times 5 times 5 4 times. Alright, so you're just multiplying the number 5 4 times, and you can see it's just the same. So you can see the difference between level 1 and level 2. It can take the same question. Alright, they're not designed to fool you or trick you, these questions. They're just designed to see if you understand powers. These are called powers, your cubing and stuff like that, squaring. Okay, now let's look at another question at level 2. Right? You may be presented with something like this. This is where your Bodmer's rules will help you. When you're dealing with Bodmer's rules, you have to do the top half first and then divide it by the bottom half. Okay, so what you do in this case is you have to find out what 15 minus 6 is, which gives you 9. Okay, and then you have to find out the square root of 9, and that's one of your basic, because this would be a non-calculator question. Alright, and we know that 3 times 3 is 9, so the root of 9 is 3. Okay, then you take 3, divide it by 3, and the answer to this question here is 1. Alright, but Bodmer's will help you solve that. Now let's look at some basic skills. Number 5, adding and subtracting. Okay. Now what we'll do here, we'll deal mainly with decimals because most of us can add whole numbers. It's fairly straightforward. Okay, so we'll use decimals. So we understand about place value. Okay, now you can see there 84.86 plus 2.56. What you must do is line up the decimal points. So you have to make sure your decimal points are lined up, all right, because that puts them in their true value. Okay, and then you add them up. So 6 plus 6 is 12, carry 1 over. That 5 becomes a 6. 6 plus 8 is 14, carry the 1 over. The 2 becomes a 3. 3 plus 4, don't forget your decimal point. 3 plus 4 is 7, and then 8. So the answer is 87.42. Now let's look at subtracting. Again, same rules apply. Line up your decimal places. Okay. Now there's various ways that you can Google and look at how you subtract, but we'll do it the old school way, the way I used to do it when I was taught, because I think that's the best. Okay. Now 7 from 6 doesn't go. Okay, so what we do is we borrow 1 from the next column because higher place value. So that 6 becomes 16. Okay, and you can see there 7 away from 16 is 9. And because we borrowed 1 from the column next to it, we have to put it back. And you can see now that 8 becomes a 9. Now 9 away from 3 doesn't go, so we borrow 1 from the next column. Okay, and then 9 from 14 is 4. 9 from 13 is 4. Okay, and because we borrowed 1, we have to put it back, not forgetting your decimal point. Okay, so that 2 now becomes a 3. 3 away from 4 gives you 1, and 0 away from 8 gives you 8. So that's how you add and subtract with decimals. Same rules as whole numbers. Now let's look at skill 6, which is multiplying and dividing. Now there you go, 235 times 25. Again, you line it up to their place values, okay, and then you start from the right and you start dealing with the units. Remember, there's your units and there's your tens column. So we'll deal with the units first. Okay, so 5 times 5 is 25, carry the 2 over. 5 times 3 is 15, plus the 2, which is 17. Okay, carry the 1 over. Okay, and then 5 times 2 is 10, plus 1 is 11. So the first row is 1175. Now we're finished with the 5, the single units, so we don't need that column anymore. We're going to use the tens column with the 2's in. So what we'll have to do is we have to put a 0 in here. We're also finished with these numbers. We don't need these numbers anymore. So we're finished with this column here, the units column. So we put a 0 in there to get started. And then we start from the 2. 2 times 5 is 10, carry 1 over. 2 times 3 is 6 plus 1 is 7. Okay, and then 2 times 2 is 4. Then to finish off the calculation, all we do is we just add them both together. So you can see there's 5, 7, 8, and then 5. All right, so that's the old-fashioned way of multiplying. Again, there is other ways that you can Google if you can find an easier way, and I'm going to show you an alternative method in a minute or two on the next slide. So that's just a way of doing it. Okay. Now decimals, this is what gets everybody. Okay. Now decimals, believe it or not, are easier than you imagine. Okay. So you look at this number here. Now imagine you don't have a calculator. It's easy with a calculator. Any multiplying and dividing is easy with a calculator. But remember, these are non-calculator skills. These are the skills that's going to get you the extra points in your exam paper. So they're worth paying attention to. Now 4.36 times 2.5, right? The first thing you do is you remove the 3 decimal places. Now you can see here, there's 2 places after the decimal point. There's 1 there. If you add these together, that's 3. And it doesn't matter how many decimal places there are after the decimal point. You add them all together, okay, and you remove them. So in this case, we're removing 3. Then you multiply as normal. So you can see there you've taken the decimal points out, you multiply as normal, and you go through the routine as before, and you come to the conclusion your answer is 10900, right? Now this is the kicker, this is the best part. You add back the 3 decimal places, and you can see there's where it fits in, okay? Then after that, you drop any zeros after the decimal point, you just get rid of them because you don't need them, okay? And you can see that the final answer to 2.36 multiplied by 2.5 is 10.9. Okay, and while you're practicing this and while you're learning this to do the non-calculator skills, use your calculator to check your answer, and that will keep you on the right track. Okay, so if you make a mistake, you can go back and check it again. Now here's the multiplying alternative if you're not if you find the old school a bit daunting. Now this is something I created myself, so this is all based on place value. All right. Now let's take 25 squared or 25 times 25 and get an answer. Now if you split these two 25s into their place value, you can see there is 25 in the proper place value, and then all you do is you draw a little grid, a little cross like that, right? And then all we do is we start with the 5. Let's deal with the 5. Okay, so what you do is you do 5 times 5, right? 5 times 5 is 25, all right? Then you do 5 times 20, all right, is 100. And then you finish with a 5. So you've done with that, and then you can go to the 20s. 20 times 5 is 100. Now this is the good part when you're doing this, and you'll see when it gets a bit more complex. See, you've got 2 zeros there. You could ignore these 2 zeros for the moment. All you need to do is 2 times 2, which is 4, and then you add the 2 zeros back in. So 2 times 2 is 4. You add the 2 zeros back in, and you can see it's 400. Then you just simply add them up, and you can see the answer there is 625. All right. So it's a way of breaking down a fairly complex old-style multiplication and putting a modern twist on it. Okay. Now let me show you a bit more difficult using 3 digits. Okay. Again, you break it down. All right. So you can see within that 3 digits, you've got a 280 according to the place value and a 4. So you split them out to their place value. The 3 and the 6 you split up to 30 and 6. And again, you quickly draw a little grid and you start using the 6. So 6 times 4 is 24. Now again, this is the beauty of this method. You don't have to do 6 times 80. It's just 6 eighths. 6 eighths is 48. And then you add the 0. That's 480. Now you don't need to do 6 times 200. You just do 2 times 6, which is 12. And then add the 2 zeros at the end. That's 1200. It's as quick as that. And once you master this skill, you can do it in seconds. All right. So now you've done away with the 6. You're now in the 30s column. So again, like before, all you need to do is 3 times 4, which is 12, and add the 0. All right. So you're finished with that. So there you go. So that's 120. Again, 3 times 8 is 24, and add the 2 zeros. Now you've got to add both zeros, and that's 2,400. Then 3 times 2 is 6, and you'll see in this case here, there's 3 zeros, 1 there and 2 there. So all you then do is put the 3 zeros back, and that's 6,000. And you add it all up, and it comes to 10,224. So that's an alternative modern way of doing multiplication. And if you prefer that to the old method, then use it. Now we're going to be dividing using the bus stop method. Okay, you may remember that from your primary school days. It's fairly straightforward. There is, again, like I said before, with other methods, you can Google other methods, but I tend to think the old one's the best. All right. So you can see there 287 divided by 5. All right. So there's your bus stop. It's called a bus stop because it looks like a bus stop. Okay, and you lay out your 287 with your 5 on the outside. So what you say to yourself is you say 5 into 2 doesn't go. All right, so you take that 2 there and you move it across into your next place value, which makes that 28. All right, so how many 5s are in 28? Well, there's 5 5s in 28 with 3 left over. All right, so you carry that 3 over into the next column. Okay, and then 5 into 37, you can see there that the answer is 7. All right, but that means there's 2 left over, so you carry the 2 over into the next column. All right, and now you're going to be dividing that 5 into 2, so you have to put your decimal point in, or you add a 0 first and foremost, right, to make that 20. But because you're working with a smaller number, you see you have to put your decimal point in. All right, and then 5 into 20 gives you 4. All right, so that's how you deal with whole numbers. But before we move on to decimals, I want to show you how to deal with an alternative method, because this is important when it comes to things like fraction. We use this method when we're converting from improper fractions to mixed fractions, okay, and vice versa. All right, so this is way old school. This is before the days of calculator. Okay, so let's do the same again. So 5 into 2 doesn't go, just like before. Okay, so you move the 2 across. 5 into 28, just the same as 5 with the remainder 3. All right, and then 5 into 37 again is 7. Okay, but this time instead of using a decimal point, all you do is leave the remainder as it is. So you can see that 5 into 37 is 7, and there's 2 left over. And that's what that means, remainder 2. So both of these answers are correct. If you put that in your answer to any question, you would get full points because they both mean the same thing. It's just that when it comes to the bottom method, we use this when we're dealing in fractions. Okay, so keep that in mind as you go forward. Now let's look at decimal numbers. All right, again, people get mixed up when it comes to decimals, but again, there is a simple answer to solve this. Now you know the bus stop method, you do the same. All right, but the difference is you cannot divide. Now remember, this is a divisor. This number here is your divisor, your dividing number. Okay, you cannot divide with a decimal. You have to make this a whole number. All right, and to make it a whole number, you just simply move the decimal point 2 places to the right, and that becomes a 5. And what you do to the outside, you do the same to the inside. You just move the decimal point to the right, and that then becomes, you just divide it as normal. So it just becomes 5 into 287, just like before, and you can see the answer is 57.4. And that's it. It's no mad, there's nothing difficult about it. You just make the dividing number a whole number, do the same to the inside, and then divide as normal. Now let's look at this one here. All right. The volume of this cuboid is 24 centimeters cubed. What is the value of D? All right. Again, this is an area where people get wrong. Okay. Now, with most maths question, they will give you all the clues within the answer how to solve this puzzle. Okay. Now it's telling you the volume, right? It's giving you the length, it's giving you the height, but it's not giving you the width. All right. But if you know from your primitive area and volume, the formula for the volume is length times width times height. So all you do to solve this type of puzzle is do it in reverse. Okay, so your starting point is 24. So you know that. You know that the formula is length times width times height. You can do it in reverse to find the missing dimension. So you take the 24, you divide it by 4. You can see you can divide it by 4, which gives you 6. You then take the 6 and divide it by the 3, and that leaves 2. And you can see that the answer to D here, or the width, is 2 centimeters by dividing. All right. Again, that would be a non-calculator paper. Okay, so just basic dividing. Now let's look at skill 7, rounding and estimating. Okay, uh, rounding and estimating are mathematical strategies used to approximate numbers, very common in maths. Okay, well, they are similar in nature. There are some key differences between the two. All right, now rounding. All right, rounding is a method used to simplify numbers by scaling them slightly up or down. It's often used when an exact number is not needed, an approximate answer will suffice. Rounding can be particularly useful when dealing with decimals. Now, anytime you see the word approximate or estimate in a question, they are not looking for an exact answer. If you whip out, even in a calculator paper, if you whip out your calculator and give an exact answer, you will lose points. They're just looking for what you call a rough guess, or as I say, an educated guess, based on loosely on your numbers. Okay. Now to round a number, it's fairly simple. You identify the digit you want to round to, the nearest whole number, the nearest tenth, etc. You look at the digit to the right of the rounding digit. If the digit is 5 or greater, then the rounding digit is increased by 1. But if the digit is less than 5, then the rounding digit stays the same. And then you change all the digits to the right of the rounding digits to 0. Now let's look at rounding whole numbers. Remember what it says, okay? Let's take 378 and round to the nearest 100. So the first thing you have to do is identify the number you want to round to. So you can see here it's the nearest 100 because it's in the hundreds column. Okay, you look at the number to the right. Okay, is it higher or lower than a 7? This one is higher than a 5. The 7 is higher than a 5. So the number goes up by 1. Okay, so the 3 changes to a 4, and then you round off the numbers. That's how you deal with whole numbers. Okay, and that's how you learn to estimate and guess stuff. It's just a rough guess, don't forget, an educated guess. Right, here's 374, round it to the nearest 10. Again, you have to identify the number you're going to round to. And you can see that's the nearest 10 is in the tens column. Okay, so you now see how place value is important in maths. Okay, you look at the number to the right, and in this case, the number is lower than a 5. So therefore, if it's under 5, it's the number, the target number stays the same. Okay, so it's 37, and then you just round off whole numbers. Okay, and that's 370. Because if you think about it logically, 74 is closer to 70 than it is to 80. Okay, and that's how you deal with whole numbers. Now let's look at decimal numbers. It's amazing the amount of mistakes that are made when dealing with decimal numbers. Now, when you mention whole numbers, they're just whole numbers. But when does a whole number become a decimal? That's when there's numbers after the decimal point. Okay, so anytime you get into part numbers like 0.5 or 0.85 in this case, right, the whole number becomes a decimal because a decimal is a number in between two whole numbers, as I've already stated. All right, so let's look at this one here. One, you've got to identify the number. So in this case, the nearest 10. You can see the 3 is in the tens column. Okay, and you look to the number to the right. Okay, and that's higher than a 5, so that 3 changes to a 4. All right, and you round off the whole numbers and drop the decimals. When you're rounding numbers with decimals on it, you just get rid of them. All right, so you can see there that 30. Remember, it says that a decimal is a number between two whole numbers, so you round it to the nearest whole number, basically. Now let's look at another one. You may get a long-winded number like this and be asked to round it to the second decimal place, and it's very common for people to make mistakes in this area. All right, but it's about identifying the number. So you identify the number, all right, and you can see in this case the second decimal place is the number 2 places after the decimal point. That's 4. Okay, so there's the 4. Look at the number to the right. You can see that it's smaller, so that 4 stays the same. Okay, so again, it's 3.74, and with decimals, you just drop them. You don't round them. You just drop them. And that's how you work with rounding decimal numbers. Now, to estimate a number, you use the information you know or you can see and make reasonable guesses about its value. Okay, so Estimation approximation is often done by rounding numbers to the nearest 10, 100 or 1000, depending on the context and the level of accuracy required. All right, and it's like I said, anytime you see the word estimating or approximating, you round your numbers off before you do the calculation. Or another way you could do it, you could add up all your numbers and then round it off at the end, but they're certainly not looking for an exact answer. You will lose points. Now here's a level 2 question you may face sometime in the future with your mock exams. And it says here, what is the approximate volume of the shape below, shape shown? Now the biggest mistake that people make is they take these numbers and multiply them and get an exact answer and they lose points. All right. What you have to do is you have to round these numbers off before you do the calculation. Now we know the formula for the volume of a cube is length times width times height equals volume cubed. All right. So this is a non-calculator paper, so it will be quite difficult to do it without a calculator. All right. So what you do is you round off the numbers, then calculate. So you can see there 24 changes to 25, 29 changes to 30, and then 41 you can round down to 40. And now that makes it easier to start calculating stuff in, and you can use your non-calculator skills, multiplying, okay? So you would eventually work out that 25 times 30 times 40 is 30,000 centimeters cubed, all right? So this is the value of your non-calculator skills. You can take something that's a relatively difficult question and make it easier by approximating it, okay? And it's a rough guess. And although it's not the exact answer, they are not looking for an exact answer. You will have some leeway, all right? You'll have some leeway as depending on your numbers, okay? So that's what you do. Now let's look at skill number 8, check calculations. Now, checking your answer. You will be asked in your exam to check your answer. And there are two main ways to do this, all right? And it's an area where lots of students lose points, all right, because they don't understand how to check your answer. Now you may have a whole list of workings in your working box and you may be asked to check your answer. Well, you don't have to go through the whole question. You just pick one part of it, usually the final part, and I'll show you two ways you can do it. All right, the first one is reverse or inverse calculation. Let's say you got 17 times 10 as part of your answer and it comes to 170. Well, you just do it in reverse. You can see there that 170 divided by 10 gives you 17. And if this end number matches your start number, then you know your answer is correct. Okay? That's called reverse calculation. Now the second one is approximate or estimate calculation. Again, very, very common in maths. You're asked to approximate your answer when you're checking it. Okay? And this is how it works. Now this may be the final part of one of your questions. Just remember it's only one part you're asked to check, not the whole thing. All right, so you can see 179 plus 103 is 282. Well, all you do is you round it off. So you change the 179 to 180, the 103 down to 100, and you can see you can quickly check the answer is 280. And you can see there that the answer is not exact, but they're not looking for an exact answer. They're looking for an educated guess. And by doing this and checking your answer as you go along, you can see that you're on the right track. Okay, it's just a quick way of checking your answer. Now there are worksheets associated with this video. If you want access to these, just email me and I will send you the details. And that is Build a Skill Number Basics. So thank you.